Good day and welcome to our class on real analysis. In today's class, we'll be proving the subsequential limit theorem. The theorem states that a sequence A sub n converges to A if and only if every subsequence of A sub n, that is A sub ni, also converges to A. Another way of stating this theorem is to say that a convergence sequence has the same limit as every of its subsequence. I've defined and tried to illustrate what a subsequence is in previous video. So we'll be making use of that definition in order to solve this. However, this is also a two-way proof. The two-directional proof because of what? If and only if. The first direction of the proof. The first direction of the proof is to show that if a sequence A sub n converges to A, then every subsequence of A sub n, every subsequent of A sub n will also converge to A. That will be the first direction of the proof. The second direction will be to show that if every subsequence of an converges to A, if every subsequent of an converges to A, then the sequence an itself, converges to A. We begin by looking at the first direction of the proof. If a sequence A sub n converges to A, then every subsequence of A sub n also converges to A. We need to make some assumption. Assume that the sequence A sub n converges to A. Then by definition of convergence, it implies that what? For any epsilon greater than 0, there exists a k belonging to set of natural numbers such that the absolute value of A sub n minus A is less than epsilon for all n greater than or equal to k. Now let A sub ni be the subsequence of A sub n. We want to prove that A sub ni also converges to A, and that implies showing that the absolute value of A sub ni minus A is less than epsilon for all I greater than or equal to k. Recall the definition of subsequence, which says that the subsequence of the sequence A sub n contains some of the terms of that sequence. That implies that given the sequence A sub n defined as A1, A2, A3 down to AN, and it continues like that, and its subsequence A sub ni defined as what? A2, A3 down to A sub I, and it continues like that. We see from there that what? A sub n1 is greater than or equal to A1, A sub n2 greater than or equal to A2, A sub n3. That means what? The first term of the subsequence is greater than or equal to the first term of the main sequence. The second term of the subsequence is greater than or equal to the second term of the main sequence. The third term of the subsequence is greater than or equal to the third term of the main sequence. Therefore, the ith term of the subsequence will be greater than or equal to the ith term of the main sequence, and this continues what? To A sub n. That implies that what? I is less than or equal to ni, and that is less than or equal to n. I is equal to ni, and that is less than or equal to n. Let I be greater than or equal to k. This implies that k is less than or equal to I, and then that implies that what? K less than or equal to I, less than or equal to n sub I, less than or equal to n. Therefore, since n is greater than k and the absolute value of A sub n minus A is less than epsilon for all n greater than or equal to k, then it implies that now that I is greater than or equal to k, absolute value of A sub ni minus A will be less than epsilon for all I greater than or equal to k, and that implies that the subsequence A sub ni converges to A, which implies that the limit as I tends to infinity of A sub ni is equal to A. Therefore, if a sequence an converges to A, then every subsequence of an also converges to A. if a sequence converges to A, then all its subsequence also converges to A. That's the first direction of the proof. We'll then go ahead to prove the second direction. The second direction says that what? If every subsequence of A sub n converges to A, then the sequence itself, the sequence A sub n itself, also converges to A. Again, we are proving, assume that every subsequence of A sub n converges to A. By definition of subsequence, it implies that A sub n is a subsequence of itself. That implies that what? A sub ni is equal to A sub n. That implies that ni is equal to n. Since A sub ni converges to A, and A sub ni is equal to A sub n, then A sub n also converges to A. And that implies that if every subsequence of A sub n converges to A, then A sub n converges to A. Therefore, we have proved the two directions of the subsequential limit theorem, which says that what? A sequence an converges to A if and only if every of its subsequence also converges to A. Thank you for watching thus far. If you have gained anything from today's video on subsequential limit theorem, like it, give it a thumbs up, and share with your friends and colleagues. Thank you. God bless you. I see you in the next video.